Okay, the purpose of this video is to describe and identify situations in which mechanical energy can be converted into other forms of energy. And we're going to do that as a part of the problem-solving process for an example with an Olympic high jumper. We've got a high jumper named Fran, whose kinetic energy is transformed into gravitational potential energy without the aid of a pole. And we're asked what minimum speed must she have to lift her center of mass 2.1 meters and cross the bar with a speed of 0.7 meters per second. So we've already got the picture, we've read the problem. Let's go straight to the law. Now this is the law of conservation of energy that says that whatever amount of total energy you've had initially, it's going to be conserved, so you'll have the same amount of energy in a final, later stage. It just might be in other forms. It might have transferred from one form to the other. The next step, we identify what forms of energy we had initially and finally. Well, our initial moment before the jump was when we were running. So we were running with some amount of kinetic energy in the forward direction before we got to this pole to jump over. So we start with kinetic energy initial. That computer's really loud. And we don't really have any other forms of energy, it's just kinetic right now. So that's it for the initial moment. But in the final stage, when we have lifted our mass up and across this bar, we've gained some height, so we've got gravitational potential. We've got the ability to fall, so we call that GPE, gravitational potential energy. And we also have a little bit of speed, probably less than what we started, but we're still moving, so we're going to say we have kinetic energy final as well. Now the next step to our problem-solving process is to apply our formulas. So we have a formula for kinetic energy. It's 1/2 mv squared. Now I'm going to put v initial, which is the speed that we're going to be solving for. So keep that in mind. That's going to equal the formula for gravitational potential energy is mass times gravity times height. So m times 9.8 times whatever amount of elevation we gain. Plus, again, kinetic energy has the formula 1/2. And now here I'm going to say final speed squared. Okay, and since we're trying to solve for initial speed, that means we've got to get it by itself. It's algebra time. So we've got this 1/2 m that we need to get rid of. So to get rid of it, we're going to multiply everything by the reciprocal. 2 divided by m, and that will get rid of the 2 and the m. We have to do that on the other side as well. And lo and behold, cancel, 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 that's all gone. And so are all of our m's, they've disappeared. And we're left with v initial squared equals 2 times the quantity gh plus v final squared over 2. So that means we can take the square root of all that, and our final solution should be v initial square root of that. Should equal, I believe, 6.45 meters per second. I'm going to use a different color so you can read the meters per second as it went over the edge there. So 6.45 meters per second is our answer for initial velocity. Okay, now you try one. We're on page 8 of your practice guide packet. Go to the teacher example and press play when you're ready to check your answer.